Hello. So I talk about negative radiation pressure, especially in context of astronomical objects, consequences, observations. Radiation pressure is just a vector, like here, this cross product of electric and magnetic field averaged. Usually, we think about positive from photon emission, which is toward the surface. It's not a problem to get a negative outward the surface. For example, reversing this magnetic field. And it's considered, for example, for metamaterials, guide medium, pulling kinks in solitons. And here we will be interested in kind of pulling energy from resonators, like in atoms. Yes, so pulling energy in hydrodynamics is very simple. Like we have this marine propeller, we can both push with this swirl-like wave forward, but we can also just reverse time, reverse rotation, and we can now pull. And if it hit a resonator, the former should be able to excite it, and the latter, as time symmetric, should be symmetrically allowed to de-excite, to drain energy from excited resonator. So now we would like to go to electromagnetism, which mathematically is very similar. Instead of electric field, the A field there is velocity, the magnetic field there is vorticity, the speed of light versus speed of sound. And there is also this electromagnetic version of this effect called Barnett effect, that are rotating even uncharged object by spinning, we get magnetic field. If we change the rotation, we get reversed magnetic field. And more practical is the synchrotron radiation. And we have electron traveling on a circle, it emits photons and it excites target. But let's think about it from CPT perspective. So we just applied time symmetry. And now this charge is traveling in the opposite direction. But the equations governing physics should be the same. So it should still emit photons, exciting target, but it is our negative time. So from our perspective, it is causing its de-excitation. Yeah, so here we excite the target, but here we should be able to symmetrically de-excite target, like for these marine propellers. Mathematically, there are these two equations. So we usually think this absorption equation, increasing the number of excited atoms, but there is the symmetric version, the stimulated emission equation, which are the time symmetric analogs, which should describe the second process, this just causing the excitation of target. So this way we can calculate the strength of the effects, and the most crucial is this, here you have this N1, the number of ground state atom, and here you have N2, the number of excited atom. So usually this N2 is orders of magnitude smaller than N1. So usually this effect is much weaker. So we need to search more carefully, and it's more difficult to find. Maybe we need to artificially excite the target. I will also briefly talk about different potential applications. For example, in Rabi cycle, we cyclically cause excitation of the target and de-excitation, excitation, de-excitation. There's also this very nice state microscope, which is recently popular, which has two lasers. So one laser causes excitation in this blue dot, and the second laser causes de-excitation in the red donut shape. Finally, subtracting by this red, we get a smaller blue green dot, getting improved resolution. And so when we talk about different applications, assuming we have this negative radiation pressure that we can literally pull up only with stimulated emission on target. For example, a CPT analog of computer tomography to map not absorption coefficient, but this time emission coefficient, and astronomical applications. And finally, there are these two-way quantum computers. So there is this symmetric formulation of quantum mechanics using these two amplitudes, which can be switched from CPT perspective. So let's think about this kind of setting that we have lasers which inject photons for state preparation, but now we symmetrically add other lasers. So now from CPT perspective, we inject laser from the photons from the second laser. So we should be able to both modify the initial state and the final state. Yeah, so we'd like to have this two-way control. If successful, they should, in theory, be able to attack NP problems and have much better error correction. Okay, so here let's briefly talk about these two-way quantum computers before going to astrophysics. So let's think about the standard electronics. We have a battery which both pushes electrons into the chip, but also actively pulls. Yes, we have two-way controls for better control of flow of electrons through our chip. Similarly, for hydrodynamics, we have a pump which both pushes fluid into, but also actively pulls it. You have two-way control, and if having quantum computers that are starting building on sort of superfluid, we would get two-way quantum computer, yes, with two-way control. And there is this similarity between electromagnetism and hydrodynamics. So we should be also be able to do it for microwaves, and maybe finally for photonics. So the question is how to build a pump for photons. And for example, this ring laser has circulation of photons in one direction. So now it injects photons here uh, for state preparation. But from CPT perspective, we inject photons here. So again, it's very similar to this pump-like setting, but now done with photons. So if being able to realize it, we should get these much more powerful quantum computers. Okay, so let's briefly talk about this CPT symmetry. So it is about charge conjugation, sign of charge, parity, the spatial symmetry, and temporal symmetry. And it is believed, so it is required for modern physics. Any Lorentz invariant local quantum field theory with Hamiltonian must have CPT symmetry. So if it will be violated, that would be very bad. We would have to change completely modern physics. So most physicists believe that it's true. However, it's very powerful. It says that running movie backward in time, that the laws governing physics should be practically the same. Yes, so and it was tested in microscopic scale for single positronium, for example. But the big question is it this time symmetry still true for macroscopic time? Yes, it's very maybe sounds controversial, but if you believe in physics, it's very interesting, and maybe we should search for applications like these two-way quantum computers. And in electromagnetics, we will focus on, we have just time symmetry. You can reverse time, and the equation should be the same. What is, for example, explored in this famous Feynman-Wheeler absorber theory with these advanced and retarded waves. Okay, so what about asymmetry, for example, in entropy growth? So for this purpose, I recommend thinking about this lake surface, which is symmetric in equations. But if we throw a rock, then the symmetry is violated. So in the solution, there is no longer symmetry. Yeah? So it's not a problem to violate symmetries in solution which are in equations. And for Big Bang for entropy growth, I think the Big Bang can be viewed as this kind of rock that everything was localized, so the entropy was low, so it created this entropy gradient we call second law of thermodynamics. We also should think about this time philosophy from this symmetry perspective. So we usually intuitively use this presentis, that there is this current moment and it evolves forward in time. However, it's not very symmetric. So in modern physics requires this modern more symmetric formulations called eternalis, Einstein's block universe. For example, in general relativity, the space-time it does not unroll, but it just is the four-dimensional solution is there. Also in quantum field theory, we work on Feynman ensembles of four-dimensional scenarios. So literally, we should think about it that space-time is kind of four-dimensional jello, and there is kind of tension from both time directions, symmetric. Like in this S matrix, we have two amplitudes because one comes from the past, second from the future. And this way, multiplying them, we get the Born rule. So Born rule literally comes from a symmetry here, which allows, for example, for Bell valation. Okay, so let's go to this Rabi cycle that mechanically there are these analogs like just coupled pendula, which periodically exchange energy. Also in hydrodynamics, we can think about this sonic wave, which periodically causes pushes and pulls this particle outside. And similarly, you should get for lasers that we can both excite target, but also symmetrically, we should be able to actually stimulate emission to cause deexcitation. Yes, so excitation, deexcitation. So let's think about some sources of photons. So beside atoms, there are also this just bending magnet, the simplest one, then up to these free electron lasers. And so the first one is later spontaneous emission. The free electron laser has later stimulated emission. And if you think from CPT perspective, yeah, so like here, you have just electrons traveling on the sine wave, emitting photons, exciting this target. But if we think from CPT perspective, we have now electrons traveling the opposite way. We should emit photons, the violet one, and excite this target. Yeah, but for us, it means causing the excitation. It should be both the absorption here, the excitation here, and the excitation here. Yeah, so it looks like if you think about CPT symmetric, also like these photons, these electrons here should also help with emission from here. So this kind of view should allow to understand better why this spectrum is going to be narrower. Yes, because it looks like these electrons further help with emission from electrons area. Okay, and in astronomy, there is synchrotron self-absorption that we both, let's say, circulate these cycling particles can emit, but also can absorb. Yeah, so we have both. So this is just coupling of two electrons with photons, and there is also CPT symmetry allows to switch these Feynman diagrams to reverse this coupling, so reverse this source and absorber and emitter. And let's think about this synchrotron, that we have these electrons circling, and now they emit photons for this target. But from this time symmetry perspective, you have still electrons going on circle, but now they emit photons here, exciting target here. So, but if you go back to this symmetry, now this blue photon should become this violet. We reverse time, yeah. So there should be both this excitation here, but also actively causing the excitation with this negative radiation pressure. You can think. Okay, so finally there is this power formula of energy loss for this electron, let's say, going on a circle. But it's like if you think about this CPT symmetry, there is looks like a problem. So why having a circling electron, it mostly emits but not absorbs? So if there is a violation of symmetry, we should see for the cause in the solution. And there is a clear answer, I think, that there are more absorbers than emitters. Yeah, so the variation of this symmetry, the CP symmetry, seems in the solution again, like for entropy, that there are more absorbers than emitters. So one of them dominates, but maybe in far future it could be reversed. I mentioned further. So here are these beautiful crab nebula and its spectrum, like 20 orders of magnitude in spectrum, in frequency, so mostly some kind of synchrotron radiation. Okay, so let's go to these three-like waves. So hydrodynamically, you can push exciting and or pull the exciting. They are switched if you reverse time. And now we'd like to do again the same for electromagnetics. Yeah, so from one side we have this electron traveling a circle, exciting here, but from CPT perspective, we reverse time. That should analogically cause excitation on negative time, so de-excitation toward positive time. Yeah, so it should both excite here and de-excite here. So let's we are usually thinking about this kind of emission, for example, for astronomical observation. Yeah, so we have, let's say, pulsar which emits photons, and it goes to the center of our telescope, which is usually cooled. It is excited, and we can monitoring. We can see where this photon come from. But now let's think about CPT analog of this situation. So again, we have coupling of two electrons, electron in pulsar and in sensor. But now we switch this Feynman diagram. Now here is absorber, here is emitter. So to observe this negative radiation pressure, you need to you need to excite our sensor instead of cooling, and again monitoring population. Yeah, so now this negative radiation pressure should cause in pulsar should cause excitation of photons in our sensor. So we should excite it and check if it does not de-excite faster than usual. If so, hopefully we have found a negative radiation uh, pressure source. So, for example, it could be synchrotron radiation, but not thermal. Thermal is only positive. But maybe we can also find some other interesting sources in cosmos of negative radiation pressure. And I will talk about the most interesting now. So the most interesting, probably for you also, it might be the white hole black hole. So White hole would only emit, that means acting with positive radiation pressure. But black hole is its time symmetric analog, so it should have only negative radiation pressure. Yeah, so believing in symmetry, it's not doing nothing, but it should actively pull energy not only in gravitational way, but also in electromagnetic way. Yeah, so like this vacuum cleaner, which if it makes this blowing in one direction, from the other it has to make suction. So if it both in hydrodynamics but also in electromagnetics, there should be also positive and negative radiation pressure, for example, through across the horizon. If here is pushing, here should be pulling, here if emit heating and cooling. So yes, I think this is the most easiest to try to search in observations. So acting with absorption equation, simulated emission equation, these two equations. So there is this problem that here you use N1, here you use N2. So usually this N2 is much smaller. So this would be much weaker effect usually. And then forms jets, yeah. So white holes would form jets going out, and symmetrically black holes should form jets going in. And so let's think about some experimental problems. So, for example, there is this black hole information paradox that they say that the information is destroyed in during this black hole evaporation, but white hole would not destroy information. It continuously exchange information by positive radiation pressure. So symmetrically, black hole should also exchange information, but now with negative radiation pressure. So I don't think there is any problem if we include that this vacuum cleaner not only blows but also have suction from the other direction. And they are observing very dynamical evolution of jets. I think maybe this kind of pulling could help forming these jets. So there is also something happening. And finally, so this heating cooling, I think, is the easiest to try to directly observe as an effect. So if you perform CPT symmetry of the white hole, which only emits, you get black hole, which also should have reverse version. So if there is heating, so now from CPT perspective, we should have cooling. And for example, I have seen some claims that there was expected a lot of. It is surprising that they see only cold gas around the Sagittarius A star, but they expected a hot one, and it's very difficult, much more difficult than expected to find. So maybe it was cooled by this effect, this CPT analog of heating. Uh, and maybe you could try to search for it in the reduction of in spectrum. Maybe we should search for this effect, but it's very subtle because again, the former depends on the number of ground state atom, but this one from the excited atom. So this is maybe orders of magnitude weaker effect than heating. Yes, so it needs very detailed analysis to try to search for this kind of effects. Another kind of effect we could try to search is this tremendous growth that this kind of pulling would help would help black hole to grow because it will not only gravitationally pull but also electromagnetically pull energy in form of photons. So maybe also it could be found. So generally this it requires a large research, difficult research. So I'm looking for collaboration to confirm or deny. So maybe we can search that there is no effect, but this way I think it would require the CPT validation. So this would be a test for CPT validation. Okay, so now there is this recent paper which sounds similar to what I have found. So negative temperature pressure in black holes is published in EPL in EPL, and also showing that the five peer-reviewed articles also claiming negative pressure inside a black hole. So as negative temperature, they say that this the statistics is reversed. So in positive temperature, there are preferred low energy states, while in negative, the high energy states. Yes, the statistics is reversed. So if having this kind of effect, we would get stimulated emission. So usually some thermal atoms would like to go to the ground state, emitting photons, so we get positive pressure. But reversing time, so now the thermal atoms would like to go to excited state, so absorbing. So it should, if this acts with positive radiation pressure, this should symmetrically act with negative radiation pressure, like this balloon which acts with positive pressure, or this rubber ball, if you squeeze, wants to go back to this maximal volume, acting with negative pressure. Yeah, so something like this should be also for electromagnetism. Okay, so here is some general picture to discuss for our discussion. So as mentioned, there was this like there's Big Bang, but the question is what is the difference between the conditions in Big Bang and if you assume that there was a big crunch. So this is assuming that there was big crunch. Maybe it's not, but recently there are some DESI uh, weakening of dark energy, so it's more optimistic for big crunch. But let's think about what is the difference between this Big Bang and Big Crunch. So from thermodynamically, like this density used in entropy formula, it should be nearly the same. So entropy should be very similar there, but it means that entropy would have to decrease finally. So finally, the entropy growth would have to be stopped and go down. So Penrose, I've seen that he wanted that entropy was reduced in the black hole evaporation. However, the evaporation means that energy is delocalized, and delocalization means entropy growth of total entropy. So instead, I think we should think about this block universe view. That there is this that there was just four-dimensional solution found in symmetric way, like the least action principle, Feynman ensembles, and we just travel through such already found solution. So and there the entropy. So here we have entropy growth, and again it should be entropy growth, but for observer going back. So we should think about what is the difference between them, and then why these now electrons, circling electron has mostly the emission. So symmetrically, I think that there should be in this far future they should have mostly absorption, yes, symmetrically, and the reason is because there is asymmetry in solution. There is more absorbers than emitter here, and here opposite. Yeah, so I think it's worth thinking about this. Also, why spontaneous emission is asymmetric. I think because of this kind of asymmetry in solution. And finally, we can think about a black hole and white hole. So there is a tendency to form a black hole after Big Bang. And if the Big Crunch is similar, it should also have tendency, but to form this symmetric version. So it should form white holes instead. Yes, so and now if black hole would survive to till the end of the time, then maybe white holes could also started here and survive to our time. So maybe we should think about white holes, how to find it. So I think it should be extremely long, yes, because it should get all the matter from outside, going from here to here, and now it should be a lone shining point, and the question is how to distinguish it. And from spectrum, I think it might probably is black body radiation, so it might be very difficult to. But I think it's worth to think about it, how to spectrally maybe distinguish white hole from other objects. Okay, so let's think about another astronomical scenario. There is this so-called Anita anomaly. That the Anita is this balloon with detectors, observing these showers of charged particles, like here. So usually that they come from some normal-looking angles. However, there are these anomalies. Are there a few events going kind of from below the Earth, like this tree here. So they were observed by Anita 1, 3, 4, but also recently by Auger observatory. So they first suspected there are town neutrinos, but finally they said a standard model is excluded now, and they search for some exotic new particles to do it. For example, that it decays in Earth and then somehow goes to the detector. So instead of searching for some exotic scenarios, so I would suggest that maybe we could think about not about pushing only as always, but maybe we could think about pulling. So now we need some very high energy, like 10 to an 18, I think F. So it's not sufficient to get some simpler mechanisms, but maybe we could think about some Feynman diagrams for pushing, for creation of the standard shower, and try to search for this CPT analog version somewhere in the in the history of the universe. So, okay. Okay, so I was talking about optical, but maybe you could think about radio astronomy. Yeah, so now we'd like to again excite the resonator inside. So we have this radio antenna, and inside the amplifier, which we would need to have excite the resonator and to check if it does not react faster than usual. And I would like to make this simple proof of concept, organize tests like just maybe two marine propeller like antennas. So we need that reversing time. This radiation pressure would be reversed, and this kind of simple antenna should be sufficient. That if you reverse time, the impulse go induce impulse, it will go in the reverse direction, so the magnetic field would be reversed. So if one would excite, like in wireless power transmission, if we apply reverse impulse, hopefully we should de-excite this resonator. Yeah, so hopefully the hope is to excite and then use the opposite impulse and try to excite and de-excite the second resonator as a proof of concept, but maybe it could have some practical applications. Okay, so much more practical applications should be medical. This mentioned CPT analog of this computer tomography. Yeah, so instead of mapping as absorption coefficient, now we'd like to map emission coefficient. So here is standard setting that we have a source of photons. They go through patient. We subtract the integral over the ground state atoms on the go, and then we measure the excitation in the detector. So now let's perform CPT symmetry from this scenario. So now you need to reverse this electron trajectory, so to act with negative radiation pressure. And now we should subtract not the number of excited atoms, but the number of the excited atoms. So this N2 excited atoms is usually orders of magnitude smaller than N1. So we should have much better transparency, like 100 times better transparency. So hopefully it should allow to make scanning of human in visual spectrum, so without ionizing radiation, much healthier. So we would need to have this negative radiation pressure and new the detectors and as in this backward telescope. So what could it monitor, scan? So there are these molecules which emit light, like they're called autofluorescent. They get energy from biochemistry. In theory, you should be able this way to make the 3D maps of this kind of molecules. So both the 3D maps, maybe 2D maps, or maybe even videos. So and now we would get this harmless, non-ionizing color, Röntgen, X-ray, video. So many improvements over the current techniques, especially this harmless and also mapping of metabolism. So new information. Okay, so if another medical application could be instead of just mapping, maybe you could speed up the excitation, especially of this NHDH, which degrades, emitting these photons 460 nanometers. So if we could pull these photons with negative radiation pressure, speed up this de-excitation, then it should then we should locally degrade this NADH, which is crucial for metabolism. So should be able to locally starve given tissue. And yes, as mentioned, it should have much better transparency because this pulling wave is only stopped by the excited atoms, which is the number is much smaller than for ground state atoms. And so here we would have like a few times speed up this degradation, while for the intermediate by some percent. So it would be negligible for the intermediate tissue and hopefully starving the target cancer tissue. So again, alternative to standard radiotherapy, but without ionizing radiation, and so hopefully it looks quite promising. Okay, so there are two experiments which might be related. So with negative delay. So there is this 2003 article that the time delay between this input and output was negative. And recently there is this negative time evidence that that the impulse going through a rubidium atom, they say, and recently it was published, they say it spent negative time. So they say it was photons go forward, then kind of go back in time, then go forward. And they published it recently. So my interpretation is that maybe this was again this coupling, but in reverse direction coupling. So maybe we don't need some going back in time, but just using that this coupling can be reversed, and so we can have also reverse coupling. Okay, so there is also some thought experiment later, but in theory allowed that in general relativity under the black hole horizon there is rotation by kind of by 90 degrees of the light cones, but in theory we could also perform 180 degrees. Yeah, so for example, in this kind bottle like wormhole, that if we travel through it, our past and future would be switched. Doing so, for example, this preparation, post-paration of quantum computers will be switched. Our standard CT absorption scanner will become emission scanner. The laser from this would have negative radiation pressure. The black hole, white hole would be switched into white hole, and so on. So I think it's not physical, maybe, but it's very good for didactics, for thinking about physics, about this time symmetry. Uh, Okay, so here is some more practical how to build this backward camera, especially maybe like here that we have this pumped sensor, the target speed up the excitation toward target, but we maybe could put some semi-transparent mirror on the go, and here put the main CMOS to get this negative radiation pressure. It looks much more practical for this backward camera for this to observe black holes maybe. And also we could think about this backward lighted camera that we have this source of negative radiation pressure, and we try to stimulate emission given frequency from the target, maybe from infrared imaging or or maybe for attacks on, let's say, on BB-84, that they try to communicate with single photons, but we make them emit more photons and get some of them and to get some information. Okay, so here maybe very briefly about this view on this positive negative radiation pressure. So here is standard picture that we have one photon and the atom they excite, we get two photons, but you can perform CPT perspective, CPT analog of this, and so literally I think it's good to think about that we create this tendency to emit photons in given direction. Yeah, so here forward, but it could be also backward. Um, Okay, so at the end, maybe let me briefly talk about these two-way quantum computers hypothesized. So in standard one-way quantum computer, you have state preparation, then some unitary operations, then finally measurements. And in two-way quantum computers, we say that if you can perform this preparation, maybe we can perform also this preparation from CPT perspective. Yeah, so if you believe in CPT perspective, in theory, it should be doable. So one way could be this I think the most promising still this pump-like setting that we have that we try to make a pump kind of, maybe for hydrodynamics is trivial, for photonics it should be doable, but if synchrotron maybe. So we had some team, some a few articles, and another approach I thought about it was this based on thermalization. So just waiting we could enforce, let's say, ground state. So, but if you wait after, then from CPT perspective, this is waiting before. So we should also enforce ground state, not only from the initial state, but also for the final state. However, so now I think there might be asymmetry, this negative radiation pressure. So I think it has very good transparency and it's clearly asymmetric. So this might be the problem, but the remaining approaches like this one should still work. And in silicon quantum dots, there is also another approach that if you have some impulse, let's say potential shape, and for preparation, and now we apply reverse shape impulse at the end. So now avoiding backward in time, we get the original state preparation. For example, here we have impulse to tunnel electrons into the quantum dots. Then we just use opposite impulse at the end, and now avoiding backward in time, we get the original state preparation. So we should choose both initial and final state. Another is that we can use strong magnetic field to enforce, let's say, spin down. But if you do it before, we get preparation. But if you do it just after, then evolving backward, we get the state preparation. So there are a few ways, maybe hopefully to get two-way quantum computers, but they are difficult to realize. And if having two-way quantum computer, then we, for example, could attack MP problem. So here is this TRISAT. Uh, so this approach very similar to Shor algorithm, like here. So in Shor, we first prepare a superposition of exponential number of inputs with Hadamard gates. Then you calculate some classical function. In Shor, it was a power. Here we use, for example, these alternatives of triples with negative for the TRISAT. And now for Shor, we would just measure them. So here we try to use this CPT analog of preparation, yes, that evolving backward in time, we get the conditions for the state preparation. So if we use one here as post-selection, but literally enforcing, then we should restrict this ensemble to only satisfying our problem, and just measuring now, we should be able to get solution to our T-set problem. So in theory, it should be work, but sure, there are some imperfections. So it's further analysis if we could practically attack. And finally, we need this operation, which is not available in this moment, but hopefully will be in a few years. But in this case, NP solvers could be achievable in quantum computers. So we should think about better post-quantum cryptography, which is at least resistant to NP solvers. The current one, I don't think is so. Maybe there are a few ways. Maybe require internalization. Maybe go to p-space. So, but this is a big topic. So I believe we should think about it seriously. That in some future there might be practical NP solvers. Okay, so here is the summary, this first summary. So how to get it in practice? Maybe we should get this synchrotron radiation to get this negative radiation pressure. Maybe the simplest for medical applications should be sufficient that we could just vacuum tube and the electrodes and the magnetic field. There should be both this positive radiation pressure but also negative radiation pressure. And there are various applications. We can think about medical, some backward camera, two-way quantum computers. And at the end, I've tried to organize. So I've convinced initially in the synchrotron Solaris, but it's very difficult to get there because you would need a line which is across the old line, so it's non-practical. Maybe it could be we could use mirrors to go up or down the lines. It's also quite difficult. So finally, the simplest way, there is this magnet at the end of linear accelerator, and if putting here, we should get the absorption, but here we should get symmetry emission. So hopefully in a few years there will be this mirror, this window to check it. And the best in Poland would be probably the Polfer for medical stations. So they plan to have these two stations. So and the second one is infrared, and this is a perfect place to for such medical station to cause stimulated emission with negative radiation pressure. So, and finally, I think there are some arguments I could be found in analyzing the data from free electron laser that indeed the farther electrons help with emission of the aerial ones, what, for example, allows to get reduce the spectrum, also angle. Yeah, so it needs to be confirmed. And so here is the summary from astrophysics perspective. So I think we should seriously consider that possibility that there is this negative radiation pressure. For example, like especially this black hole is as white hole should hit around, so black hole should cool around. So it's more worth to search for this kind of effects, but there are quite subtle because especially that this heating is proportional to number of ground state and the cooling is to excited, so usually this N2 is much smaller. So we should search it for some surprisingly cold matter like around the Sagittarius A, some dust, maybe could be explained this way. Also faster growing, there are many this kind of news that the black hole is growing much faster than expected. Then maybe you could get this direct observation by building this backward camera that with sensor of constantly pump sensor and no, what's happened? with constantly pumped sensor that we monitor its population. Or the simpler realization could be like here that we have this semi-transparent mirror, and here is the um, uh, main matrix. So this it has been pumped, for example, at 3 level. There are these semiconductor optical amplifiers, erbium, some dyes could be used. Then there is we could search for this CPT of so processes which are CPT analogs of push scenario. So pull-like scenarios may be in Anita anomaly. So maybe you should think about potential cause of this anomaly, this not as pushing through Earth but pulling from above. Finally, there is this, I think, very interesting question you should think about: why circulating electron emits but loses energy but not gains. Yeah, so this sounds against CPT symmetry, but so we need to find the solution in the conditions that there are more absorbers than emitters. And finally, I mentioned that if after black hole there are after Big Bang there are black holes, so maybe before Big Crunch there should be formed a white hole. So and maybe some could survive to our time. So maybe we could think about what kind of spectrum should we expect, and there would be later lone objects. So maybe we should think about it. Thank you for the attention.